Hi there, welcome to the Robot program. I'm Professor E. In this episode, I'm going to show you how you can use RoboScratch to navigate a path or a maze. We've set up this little obstacle course over here, and I am going to write a program that allows Six to navigate around these obstacles. You can do this with any of the Revolution robots. To get started, I'm going to load the Easy Builder software, and I'm going to go into my bookmarks menu here and click on Example Projects. You want to open up the project that's the Bear project for your robot. So if you're using JD, open the JD Bear project. If you're using Six, open the Six Bear project. Roly Bear, and AdventureBot, open the Bear project for AdventureBot. Just click the green Open button, and this will open up the Bear project. The Bear project is a nice clean workspace with minimal controls. Turn on my robot here. I'm giving it lots of room. Go into my Wi-Fi connections and connect to the EasyBee V4 connection. All right, back in my project, I'm going to click the blue Connect button. And he's in the initialization position. Great. Now, we don't need to add any other controls for this project, but if you want to see what the robot is watching, you can go ahead and add the camera control. Which is what I'm going to do right now, just because I like to see what Six is seeing. And click the green button to start. Okay, there we go. All right, I'm going to go ahead and put Six down on our obstacle course. We're going to write our program using the RoboScratch workspace. So under File, click on RoboScratch, and we can see what Six is seeing in the camera preview, and this is our blank canvas for writing our program. We're going to write a program that allows Six to navigate around the obstacles. That means we need to understand how he moves forward, how he turns, and how he goes backwards, depending on how we want to move around the obstacles. So I've placed Six in a nice clear area where he's got lots of room to move. And the first thing I'm going to do is just understand how long it takes Six to move and how much room he needs. So I'm going to go into Forward. I want Six to go through this obstacle course fairly quickly, so I'm going to go around 225. It's almost his top speed. Okay, let's just change the time to 2 seconds. When I click Start, we're going to see how far he can move in 2 seconds. Okay, so about half of one of my blocks, maybe a little bit less. All right, now let's see if he turns right. How long does it take him to do 90-degree turn? So again, I want to go about 225. And I'm going to guess around 5 seconds. So let's delete the forward code. So all we're going to do is move right. So he's facing forward, and I'm going to click Start. Let's see how many degrees he can get around. Perfect. So at the speed of 225, it takes Six about 5 seconds to do a 90-degree turn. This is going to be important because when we go through the obstacle course, we want to go straight, right, left, or maybe even reverse. Now that we know all of the movements, we can go ahead and code the program for getting through this particular course. So I'm going to clear my workspace here. If we take a look at the course, we want Six to start between the two red pylons down here. We want it to go straight, turn to the right, avoid Darth Vader here. So he'll have to turn left, go straight, avoiding Wally, avoiding the rest of the pylons and the other blocks, turn right, go straight, turn left, and go out the other end between the red pylons again. So we're kind of going in almost an S shape. We can add the code blocks that represent those movements. So the first one is forward, and then he has to turn right, and then he'll walk forward towards Darth Vader, and then left, and then go straight down that long path, and then right, past those yellow pylons, forward again, then left and forward to go through the last two pylons. Okay, so we know those are all the different movements. Now we have to decide on the speed and how long we want each of those movements to be executed for. In our tests, we chose a speed of about 225, and I'm going to keep it at that speed. I like him moving fairly quickly, Maybe you're in a race against other robots, or maybe you want him to take his time, take the scenic path. You can also choose a slower speed. I've changed all my speeds to 225. Now I need to decide how long I want each of these movements to be executed for. So we know roughly how far he can move in those 2 seconds that we tested. So if he's starting between those pylons, I want him to move forward for just about 1.5 seconds, which we've already got here. Now we know a right turn, a completely 90-degree right turn, takes about 5 seconds. So I'm going to change the first right turn to 5 seconds, and now he'll be pointed at Darth Jader. And he has to move forward. That's a pretty far distance between the pylons and Darth Jader. So I'm going to give him about 4 seconds. Now remember, you're estimating these times to start with. Once you actually run the program, you'll be able to tweak the times to see if he runs into any obstacles. Maybe you need to turn a little more, maybe you need to go a little further forward. You're going to see that when you run your code. So once he moves forward and we hit Darth Jader, we want to avoid Darth Jader and the yellow block, so we're going to turn left. And we want a completely 90-degree turn again, so we know that's about 5 seconds. Now Six has to move down this straight path in the middle, where we were doing our testing. That's a pretty long distance. If we gave him 4 seconds to go from pylons to Darth Jader, let's give him 6 seconds to get down that straightaway there. So this is good. He's going to go past Wally, past the green blocks, but we don't want him to go off the carpet. We want him to turn to the right and come back. So his next turn, again, we want a completely 90-degree turn. It's about 5 seconds. And he's going to move forward in between the pylons and those yellow pylons down at the bottom. So let's go about 3 seconds. It's not very far distance. All right, now his last turn, we want to angle him so he's going between the pylons and out the end. So again, completely 90-degree turn for 5 seconds. And I'm okay if he runs right through the pylons, so let's do 4 seconds. I want to make sure he turns completely and goes right through our finish line. Okay, so now that we have our estimated speeds, we can do a trial run and then tweak any of the numbers that need a little bit of adjusting. So let's place 6 where we want him to start the course from. Now you'll notice that we're using foam blocks to create the floor for our obstacle course. That's because 6 might have a little bit of trouble moving on our hard floor. We've got lines in between the tile and he might slip. Depending on what surface you're using, you can test to see how your robot moves. As always, to run our code, we're going to click the green start button, and let's see what 6 does. So forward, turn to the right towards Darth Jader. Come forward. Uh-oh, he's going to hit that orange block. So maybe we need to turn a little bit more. Oh, we didn't come forward enough either. Coming forward, past Wally and the green blocks, which is good. Oh, he needs to go a little further forward because now he's not going to be able to clear the yellow block. All right, so I'm going to go ahead and stop that code. So we can see this is an example of how we'll have to tweak the values within our code. I'm going to go ahead and adjust those values, and then we can see his final run. And go. In this episode, we demonstrated how to use RoboScratch to navigate an obstacle course. You can use any of the Revolution robots, but in this example, we used 6. Open Easy Builder and connect as usual. You want to make sure you're using the bare project for your robot. Use a fully charged robot to make sure you have enough battery life to make it through the entire obstacle course. Our obstacle course was a mix of pylons, other robots, and even some foam blocks. You can create whatever obstacles you want, or even have your robot move around a room or a space, something that already has furniture or obstacles in place. We built our program using the RoboScratch workspace. When building your program, you have to consider the different types of movement that your robot is capable of. How your robot moves may depend on the surface that it is walking on. Consider whether you're using a hard floor or a carpet or a foam surface like we did in this example. We wanted to use a combination of move forward, move backward, move right, or left to get around our obstacles. To do this, you have to understand how each of these movements works for your robot. You can do this using rate and degrees of movement. You'll want to see how long it takes your robot to move forward in a straight line. Add a forward movement block and choose a speed depending on how fast you want your robot to go. I wanted the robot to take the obstacle course at a fairly quick speed, so I chose a speed for 6 around 225, almost near the maximum speed. Once you've chosen your speed, see how far your robot can move in 1 or 2 seconds. This way, if you need your robot to move a really long distance, you'll know if you need 10 seconds or 15 seconds. You'll be able to make a more educated estimate. Do the same thing for turning right or left. Using the speed that you want, again, I chose around 225, test how long it takes your robot to do a 90-degree turn. This way, if an obstacle is facing your robot head-on and you need to do a complete 90-degree turn around it, you'll know exactly how long it takes your robot to move those 90 degrees. Maybe you need your robot to only move 45 degrees. Using math, you can divide how long it takes to move 90 degrees, and then your robot will only move those 45 degrees. Once you understand how your robot executes particular movements, you can outline the script for executing the entire obstacle course. Use the green Start button to run your code and tweak any of the values that might need to be adjusted. These trial runs let you see if your robot is not turning as much as you want it to, or if it's running into an obstacle just at the very end, or if you just need to change things a little bit. Once you have the speed settings and time settings exactly how you want them, you can run the entire obstacle course. This knowledge will be useful in future activities if you need your robot to get around an obstacle, or if you just want to execute movement in a very specific way. There are lots of practical applications for executing this type of robotic control. We can't always have a human operator controlling how the robot moves. Instead, we write a program, and just by the click of one Start button, the robot will execute the entire path or the entire obstacle course. This could be helpful in a disaster recovery situation where we know there's a big obstacle in the way, but we want to see around it. So we tell the robot we need to move forward, right, left, and get around the object. Or even things like the Mars rover as it's exploring a new world. We can send it instructions, have it execute those instructions, and get back the pictures or the samples that it's been able to get. You can use this activity to explore your creativity by choosing new and more challenging obstacles every time. Thanks for watching this episode, and we'll see you next time. Why should you test forward movement speed? How many degrees of movement is a complete right or left turn? What is a practical application of obstacle navigation? Find the answers at therobotprogram.com.